Hello. I hope everyone's enjoying the 21 Indiana Safety and Health Conference. When the call first went out for presenters, I said, yeah, sure. I enjoy presenting. So yeah, here's a topic that I'll happily speak on. Things went as things are, and this doesn't actually meet my style. I'm very animated. I move around. I don't stand behind a podium. But being that as it may, we're going to do what we need to do. So, without further ado, all good safety programs, meetings, sessions, whatever, starts with an emergency action recap. I don't know where you are, but I assume you know how to get out, at least one, if not two different ways. And I assume you know where your facilities are. I know where mine are, so we got that out of the way. As part of the program, these were the items that we said we were going to discuss: the three biggest lies in electrical safety, the marking and labeling requirements for equipment, best practices, process auditing, points for lockout, tagout, or control of hazardous energy, as well as robotic cell safety, and today's NFPA 70E standard review. I think it's important everyone know upfront what I am not versus what I am. I am not an engineer, electrical or otherwise. I am not an electrician by trade. And I haven't played either one of those on TV or stayed at a Holiday Inn lately. So, however, what I am is old. You can see that from the video part. I came into the safety profession in the mid 80s. I had done my 20 years on the street as an emergency paramedic, special rescue team member, specializing in hazardous materials. So that's why industry asked me to join them, was my hazmat background, because in that same time frame we had, aside from employee right to know, we had community right to know, and all those aspects. So that's what got me off the street and into industry. Again, middle 80s, hazard communication was a hot button item. Also in 1990, the hazardous energy control standard, lockout tagout standard came in. We had early nurturing as more robotic cells were becoming more popular in the industrial manufacturing environment. And then, of course, in the 2000s, we had the 70E electrical safety standards kick in. Again, when I left the street the first time, I began my career at a plant level in high voltage transmission and distribution components, the switchgear, the large breakers, the lightning arresters. One of the tasks in the facility was we had our own lightning room, 500,000 volt generating room. We made our own lightning and we directed it to our components to see if they would fail. So high voltage was nothing new to me from that environment. A few years later in my career, I went as the corporate safety and risk manager in the fiberglass manufacturing industry. Had North America was my territory, and making fiberglass is also a high voltage process. So I've been around it for a long time. In addition, I've done consulting work for about 6 years. And with that, I've also been in the automotive manufacturing facilities. I've been in their sub-tier supplier facilities, general commercial and industrial construction, the pharmaceutical industry, and somewhat regrettable, the food processing industry. They say if you go to one of those facilities, you tend not to eat that food anymore. And yeah, I can see why. No insult intended, just reality. I still stay in touch with people that I've worked with. They are still at company levels. There's other people I've met through doing presentations and trainings, and I do talk to them, and I ask them how they're doing, what's new, what's going on, and it's you know, Kevin, it's meeting after meeting after meeting. That's all I get done all day long. We have meetings to discuss the previous meetings. What did we not get accomplished? And then have the plan for the next meeting. Primarily, they're asked to continuously improve, develop, or implement new processes or update the existing ones, but of course with better metrics. And one of the primary metrics is lowering the cost or the expense to the business. And you got to be able to measure them. The directs are simple, the indirects take some work. So that's a pretty fair amount of time when you're not in a meeting. And then, of course, all businesses, all industries, OSHA compliance is the minimum requirement, and we want to get past minimum standards. We want to be in the best practices mode. We want to be an industry leader, or at least up there with our industry leaders. And, you know, never fails every day. How many fires do we have to go to and deal with? Priority of those fires are not necessarily your priority, but somebody's priority. And then, of course, you always kick in that wonderful line that's on all our job descriptions everywhere: any other assigned duties. So when we do that, we find ourselves busy. And when we're busy, we tend not to get other things accomplished. When I am asked to go to a facility to do an electrical safety assessment or do an electrical safety training session, I like to sit down with the plant personnel. Many times it's been the corporate representative, as we're going to set this up for multiple facilities. And so I have a series of questions that I ask them. And I am comfortable in saying that we have the three biggest lies in electrical safety. The first one is clearly, I always hear, oh, our employees do not work on live circuits or voltage above 240 volts DC. It's consistent. We do not do it. It is our policy that we do not do these things. Obviously, that's in a policy vacuum room because no one has ever asked their qualified electrical staff. Because when I go to do the session, the first thing I ask those people are, do you work on live equipment? Invariably, they all say yes. So there's a disconnect. You can't just say in writing that we don't do it when in reality we are doing it. I'll follow up with that plant or corporate person and I'll say, well, do you have these items for electrical safety? Do you have the different Cat 2, 3, 4 clothing? Do you have the special headgear and face shields and the gloves and the tools? And they say, oh yeah, we got all that. We got 2, 3, 4, we got gloves, we got face shields, we got insulated tools, and we even have hot sticks because we use an overhead bus system for supplying high voltage electricity to different locations in the plant. But if you're not working on it, why do you have it? If your program states we do not work on anything above 240 volts, then you don't need this equipment. But we have the equipment. Why? Because we know, in fact, they're doing it. So something we have to work on. Several facilities have also said, hey, we've redone all our lighting panels for increased efficiency, lower electrical demand. And what we have done is upgraded everything in our lighting to 277 volts AC. So we're below the 480 threshold. Really? I'm not an electrician. I told you I'm not an electrician. Maybe you got 277 going out from the circuit breaker box, but the feed into that box is 480. The feed from the distribution panel going to the lighting panel is going to be 480. The only thing they did was they dropped the ground off on the individual components. That's how you get 277. And then, of course, you ask, well, if you have something that needs to be looked at, you have to troubleshoot it. You can't troubleshoot a dead circuit. I don't care what the voltage is. If it's dead, you've turned it off, you can't troubleshoot what the problem is. Therefore, your qualified electrical workers are going to be testing. Testing is touching. And if it's 480 or above, you're in 70E, and you have to monitor and provide all the information and all the equipment. You can't say, oh, we don't work on it. You do. You should know that you do. And then there's other live work that's being performed. Again, meeting with, talking with your qualified electrical workers, you might be surprised as to what you learn. Why number two kind of plays into one. Oh, don't worry about it. It's okay. It's de-energized. It's dead. The most important phase of the control of hazardous energy standard on the electrical side, on all sides, is the fact that the person's required to verify that, in fact, they have reached a zero energy state. You have your affected employees. We train them all. Hey, you may see these things. We have a lockout, tag out program. And if you see these things, leave them alone. Don't touch them. You're not authorized. And then we bring in our, let's say, machine operators and say, we're going to train you how to perform a lockout. You're going to need to do that on a regular basis to make whatever changes or adjustments to the equipment you're operating. We're going to make you an authorized employee. Those folks will go to the electrical supply. They will open the disconnect, or they'll say they'll throw it to the off position, or they'll turn the rotary switch to the off position, or whatever the switch mechanism is for the machine. They'll apply their lockout device, and then their verification is they will try to start the machine. They will try to start the process. If the process does not start, then they have a successful lockout. They have verified it. Qualified electrical workers, on the other hand, are a step up based on knowledge, experience, be they trade certified, whichever, whatever. They are not going to simply throw a switch, put a lock on it, hit a button, and then go from there. Their verification is going to involve testing. They're going to use their meters. They're going to take their meter and they're going to read it. Once again, testing is touching. So if it's a 480 feed, if it's a 480 disconnect, They have to be in the appropriate PPE when they open it and test it to verify that, yes, in fact, it's dead. If the authorized employee goes through their steps, hits the button, and the machine starts, they have not verified the lockout, they don't have verification, they're going to have to call for help. That's another time when your qualified electrical worker is going to use testing equipment to achieve a zero energy state. You can have local disconnects, you can have line control panels, you can have an MCC, you have your distribution, be it a distribution panel or a lighting panel. It goes back to the subroom. This is important. Knowing how far back something goes is important, so that if you have to go to the next step, the next level, you can do so. We'll get to that when we talk about marking and labeling. So if you have affected people, you know that we have training records for them. If we have authorized personnel, we have training records for them, the machine operators. And then our maintenance folks, our facility electricians, our qualified electrical workers, they have their standards, they have their training, and we have records for that. But do we have procedures? Do we have all these levels recorded? And are they audited? We know in lockout tagout that you're required at least an annual audit of your lockout procedures for those people performing them. So you should have that record. We should know what are the verification steps for each person, each level of employees, so that we can ensure that that is taken, that's written, it's documented. One of the more common things that I do come across is the program folks. A lot of things today, the machinery, we have different logic drives, we have PLCs, we have other methodologies. And invariably, you walk down an aisle, there's a cabinet that's open, there's someone, ironically, sitting on a folding metal chair with their laptop on their lap, and they're just programming away. The cabinet is a two-sided cabinet. Usually the right side, as you're looking at it, is the power side. If it's a line drive situation or setup, you're going to have high volt. Well, you're going to have 480 volts in that side. OSHA considers anything at 600 or above high voltage. NFPA 70 says we kick in at 480. Regardless, you're going to have a two-sided panel. The programmer's got the doors open. He's only working or she's only working on the PLC or the logistics side of the panel. If there is not shielding between the power side and the PLC side, or if there's no separation, those folks are being exposed to whatever that voltage is. That's a problem. Something we need to be aware of. A lot of times these dual cabinets, the disconnect is always going to be on the right-hand side, usually up in the upper right corner on the outside of the cabinet. People in the PLC and logistics world don't like when there's no power. Now, what they got to get in to make a program adjustment, what they tend to do is kind of start to open the disconnect enough that it bypasses the interlock on the cabinet opening knob, and that's how they get the cabinet open without disturbing the power. Again, obviously that's a problem. Another issue that we come up against in today's world, particularly everybody now understands remote working because that's where we've been because of the COVID-19 pandemic. That's why we're doing things the way that we're doing them here through this presentation versus live presentations. So we have people that are making changes in PLCs and programming and logistics from remote locations. When that happens, they need to be aware that there's ongoing maintenance or there is an issue at the location that they may be remotely trying to tap into. Again, can create a problem for your employees. Our safety process program covers everything. It covers that. Well, then I find myself saying, which one? 1910-147, lockout, tag out, control of hazardous energy, or are you in the general electrical standards, 301 to 399, or you're talking 70E, or are you looking at incorporated by reference relative to robotic work cells? Many places today still have an individual control of hazardous energy program. Their maintenance department will have a electrical safety program. And if you have robotics, you may also have a robotic program. A lot of facilities are finding now, and that this is something that we do, we write total electrical safety programs. It's not something that you just all of a sudden create. It's not something, oh, I can spend 4 hours on my computer, I can put all this together and now we have a total plan. It doesn't work that way. It's a collaborative effort between the facilities engineering group, the facilities maintenance group, your production folks to understand what their role and their tie-in is. And if you're an ISO facility, you need to include the ISO folks because that's going to impact the things that they do. This is 101. All electrical installations, all electrical cabinets, all electrical switches at a bare minimum have to be marked with their voltage on the outside. You go through a lot of places, they don't have it. We have 4 different examples here, none of which have what the voltage is marked on them. So you could say you have 4 separate actions that this particular facility can face. You can do it as simply as taking a Sharpie and writing on the outside. What is it? 110, 240, 480, whatever. Commonly, we do see the orange background with the black numbering and lettering that says, 240 volts. That's good. It's better than a Sharpie, but the Sharpie is the exact bare minimum that you can do. Should be aware. As we looked at a little bit better example, this particular box tells us what it controls and that in fact it's 480 volts. That's good news. That's another step in the right direction. It meets the minimum that we're looking for. This is a step up. This is more considered a well-marked one. It tells us what it is. It tells us what the voltage is. It tells us what MCC bucket it's fed from and what other panel it's fed from. This is more information. This would be one that would be better if this is what's seen in a facility. You know that they have gone and marked backward and decided what feeds what, so that we have a path that we can follow. One would argue this is a fully marked switch. It has the voltage, it has an arc flash warning, it has all the information. We know that it is a particular panel, and we know the various locations where it's fed from, taking the system back to the subroom. This would be a good example. If you're 480 and above, depending on when you did your facility review, you have label standards that you have to meet. If you go all the way back into the beginning, the simple danger arc flash hazard label is there. Do not operate without proper equipment, failure to comply, blah, 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 blah. That was from the initial. Then it progressed up to, you need to have a label that talks about, at a minimum, the prohibited boundary that's established based on the table. You need to identify what level of PPE is required to be worn. It depends on what methodology your facility used. The simplest, cheapest, for lack of a better term, is to use the 70E tables. If you go through the tables, you can identify what you do, what your risks are. You can identify, based on what you do, based on the equipment, what your PPE level of required 2, 3, or 4 is. If you have gone through the steps to do the calculations, that means that you have a single line diagram for the facility. You have a short circuit analysis. You have a device coordination study. And additionally, you have a line, typical line drawing. If you have those 3 things in place, now you can do the 70E calculations. Those are more specific. They're going to tell you what is the incident energy at any given point in your process. That, if you do that, then you have that on the label as this is the incident level. These are how many calories per centimeter we're going to be involved with. What is my prohibitive boundary? What is the individual PPE requirements? So the 70E at an exceptionally extreme minimum is simply a label saying there is an arc flash hazard, and now your qualified staff have to work backwards to find out. Or you can have one of the other labels that identifies based on the tables or based on a full study. One of the things that's kind of critical, and I have seen in multiple places, is equipment that's powered from remote sources. You have the local disconnect on the equipment itself, and you think that if you open that disconnect or you turn it to the off position, that your power is interrupted. But, oh, it's fed from another location as well. If that's the case, you need to have the additional label on. Obviously, this label does become very important, and nobody gets surprised. This particular facility, it's a commercial electrical room. This is the switchgear. Because it's a commercial system, commercial setup, the only thing the public utility brought in was 240 volts AC. But it's in a secure electrical room. So while it doesn't pose a high hazard relative to arc flash, it still is not accessible by anybody, everybody in the facility. Your switchgear rooms, be they commercial or industrial, must be secured, which means there's a door. The door is locked, and you have limited people with access to the key or that have keys that they can access the room. On the industrial side, you'll have an MCC located in the subroom. This is a positive move. MCCs, generally speaking, are going to be in the 480 and above category. And when something goes wrong or something needs attention, it's in the secured subroom. Again, by having it in the secured subroom, no one has general access to it. If you don't have it secured, what happens? It becomes a storage closet. And things that are not supposed to be in there tend to grow in there. So keep your rooms locked. Also, by having your MCCs in a subroom limits the exposure that your employees may be dealing with or are going to have to face. This is an MCC located out on the production floor. This is an older methodology. And okay, you know, it's not improper, but you need to recognize that not only are your qualified electrical people working on it at risk, the people that are working in the area are at risk. And if it's a travel aisle from other locations within the facility, those people are at risk. I don't know if it's Murphy's Law, karma, or which, but you know, the bucket that needs attention or needs to be replaced or has failed is never the bucket right in front as you're standing there. It's always the bucket up on the top level, or it's always the bucket at the floor level. Putting your qualified electrical worker in a position of increased risk. Not only are they at an increased risk, but now it's imperative that you set up your prohibited boundary. You have at a minimum cones and tape, be it 4 feet, 6 feet, 9 feet, whatever the table calls for, preventing anyone from getting into that area, or physical barrier. Someplace uses plastic type barriers that they set up temporarily. When an employee walks by and they see somebody in a Cat 4 suit, it's not something they see every day. So what is their normal curiosity? They want to go up and look close. You need the barrier to keep them out. In the event that something goes wrong, there is an incident, it minimizes those that are going to be affected, and clearly those that are not wearing that suit are going to be affected. So it just demonstrates that there's a heightened risk in a facility where your MCCs are located on the floor level. If you have robotic cells, then you have need for robot safety. Robot safety has been around for quite some time. It initially started with the Robotics Institute of America. They were the ones that generated how to utilize, how to install, and what the safety requirements were. Why did they do it? Because there is no OSHA standard for robot safety. They have, however, incorporated by reference the ANSI Robotic Institute of America's combined R15.06 standard. So the standard exists. It's incorporated by reference. There are specific things you are required to do, and enforcement actions can be taken against you either under 147, under 212 for machine safeguarding, the good old general duty clause, or something from the general subpart S electrical safety section of 1910. So just because there's not a particular OSHA standard, these have been incorporated by reference, therefore you have to follow them. If you fail to follow them, you can be fined or cited as a willful. We'll talk about that in a minute. This is the minute. The vendor, the integrator, or the installer is required to provide you with the initial risk assessment for that robot operation. Usually it's the vendor integrator. They give it to you, they install the equipment, they make sure the equipment checks out, they turn it over, now you're going to put it into production. Once you take that robot, you have to have a risk assessment document. A lot of places do take the vendor integrator's risk assessment, they just change the title on it and they make it their own. Okay, you should do your own. Once you have that, you're meeting the law. Oh, until you make a tooling change or you change the programming or decide that we're going to also include this other area over here. We're going to put another operation in there. So you're doing a layout effect, or you're changing your policies and your procedures. If you do any of those things, you have to conduct an updated risk assessment. So if there's an inspection, if there's an investigation, hopefully not, but if there's an investigation, they're going to ask for your latest risk assessment. Let's say the robot was installed in 2013. They're going to ask for the vendor integrator's risk assessment and your last risk assessment. If you bought it and put it in 2013, and you did a second risk assessment when you went into production in 2013, and now you have an incident or an inspection, and they say, let me see the latest, and you still give them 2013, they're going to ask you, your employees, have you made a tooling change? Have you done any programming changes? If the answer is yes, they're going to say you need to have another updated risk assessment, and that is the willful violation. Because the agency adopted incorporated by reference, that is the law. If you don't do that, you can't say, oh, I didn't know. That becomes a willful violation. So definitely something that you want to pay attention to. Methodologies, ways to stay in best practices. Externally, you're here. You're attending the state conference. You can have other externals, the ASSP, the NFPA, the Robotics Institute of America, National Safety Council. Everybody has an organization. A lot of places have local chapters. You can attend chapter meetings. You can see presentations that they have. You can read articles, white papers. A lot of the larger ones have individual journals. When they have the individual journals, it could be digital, could be print, you could get both. In all your spare time, in your leisure, these are things that you can utilize to stay up to date. What are the best practices for general safety? What are the best practices in your particular industry? Good things to be aware of. The whole world is based on relationships. How you approach, how you work with other people, how you receive information, it's critical. You cannot be just the safety person. If your facility, your company, your corporation has a project engineering team, they have plans that they've made. What are we doing this year? What are we doing in 3 years, 5 years, 7 years? When those plans are being developed, that's when you want to be involved. Making an impact in the front end makes life a lot better. Your plant engineer or your maintenance manager, they know things that they're going to revise, not necessarily a capital project, not involving the project engineering team. It's just things that they can do within their scope of work. So they're going to work on it. You need to be aware of those changes. How does it impact the safety of your employees, but how does it impact your electrical safety program or individual electrical safety programs? Again, there's nothing worse than having something be put in place and then safety come out and say, well, we need to do this, this, and this. Should have been done on the front end. If there's a best practice for something, that is the time to get it implemented. You may not get everything, but it's a step towards a total best practice. That's why you want to be involved in the front end. You will never be successful if everything you do is at the end of something and now you want to go back and retrofit it. It will destroy your relationships and it will also have negative impacts on getting those things accomplished. If you have safety committees, if you utilize safety observers in your program, or you're an ISO facility, you obviously have ISO auditors. These are also folks that can be very helpful to you. But you have to keep them up to date. What are some of the best practices for our industry? What changes are we implementing? And oh, by the way, if you see open cabinets, let me know. If you see a cabinet not marked, let me know. Things that seem to get lost in translation. Management, by walking around, has been around longer than I have been in the safety community. But if you're going out onto the floor to answer a complaint, to look at a situation, to do an accident investigation, while you're going out there, just pick a couple of items electrically to look at. Are cabinets open? Are cabinets marked? If you walk by the electrical room or the sub room, try the doorknob. If it opens, make a note. You got a problem. You got to check on it. If you have contractors on site, you cannot just let millwrights and electricians run ragged. You can't just say, yeah, go ahead, we need you to move this or put this new piece of equipment in. They have to be integrated into your electrical safety. You can't say your program has to be at least as stringent or as strict as ours, and you need to follow this. You have some serious control, or you can have some serious controls, particularly from a best practice point of view, so that you don't have something go wrong in your facility based on their actions. And again, if you didn't know they were going to be there, you need to work on that relationship. You need to be aware that they're there. These are process improvements that are fairly simple to make. So these are things to look at, things to consider. And if you're out and about, you can just go down your checklist and you can address them, or at least make note of them so you can address them in the next meeting and the meeting after that. Sorry, I couldn't resist. So I feel like this dog. Is it over yet? Yes, it is. I hope you found some of the information at least valuable as to what you have, things to look for, things you can improve upon. And I guess we'll be answering questions that come up. I hope you enjoy the rest of the conference and that you continue your path to having best practices in your facility, not just for electrical safety, but safety in general. Thank you.